So let's start here with the topic power. You know, power. What is power? What is power? Very good. Rate of doing work is called power. Power is defined as rate of doing work is called power. Rate means that power is equal to work upon time. Work done upon time taken. Work done upon time taken. So power is equal to work done upon time taken. So what is the work done? What is the work done? Work done, force into displacement. Same work that you have done before. Yes. So that is equal to the work done is equal to force into displacement. So here you see that power is equal to rate of doing work. That means work done. The same way you will calculate the work done and then divide it by the time. So when you divide it by the time, suppose there are two persons and both are doing the same work. There are two persons and both are doing the same work, right? Two persons are there, person A and person B, both are doing the same work, right? So when both of them are doing the same work, one is doing it faster, another is doing it slower. Okay, understood? One is doing it faster, another one is doing it slower. One is doing faster, one is having higher speed, more speed, so he is doing faster. Another one is doing slower. So when two persons are there, one is doing faster work, another is doing slower work. That means this is called as what? This is called as that the person who is doing faster means who is taking less time, his speed is more. His speed is more. That means he is doing work faster. So his power is also more, right? So power is inversely proportional to time taken. Greater the time taken, the less is the power. The less time taken, more is the power. See, here it is down. Can you see that? This is down. So you see that the power is equal to rate of doing work, and the power is equal to work done upon time taken. Power is equal to work done upon time taken, right? So whatever is the work done and upon that time taken will be called as power. So power is equal to rate of doing work, that is called as work done upon time taken. Is it clear now? Now write down a numeric table. Yes. Write down a numeric. Its unit is a watt. Unit is watt. WATT. Named after the famous scientist James Watt. Do you know what James Watt invented? James Watt, what did he invent? He invented a steam engine. He invented a steam engine because of whose development, or because of whose which when this steam engine was developed or made, so it made the work easier. It made the work easier, so that the work that was done initially, it was taking plenty of time, now it was done in small time. Okay. So at that time, in olden times, there were plenty of coal was there, water was there. Okay, so this coal was found, and this coal was used to generate energy, and because of that, the steam engines were working. So this created a revolution. This created a revolution that is called as industrial revolution. You must have heard about it. Industrial revolution was caused because of this. So James Watt was a very famous scientist and physicist, you can say. And James, he invented this engine. That's why he's also called as he's also the producer of this engine. So the power is equal to work done upon time, and this SI unit is watt. The higher units are kilowatt hour, kilowatt or kilowatt. 1 kilowatt means what? 1000 watt. And then another unit is 1 kilowatt hour. Kilowatt hour. That means 1000, 1 kilowatt, and then hour means what? 60 into 60 seconds. 1 hour has got 60 into 60 seconds. So 3 into 3, 6. That is 36 into 10 power 5. So this can be written as 3.6 into 10 power 6. है ना? This much. This is the this much watts, right? So you can also call it as joules. It's measured in terms of joules. What kilowatt hour is called. This is the SI unit of the electric meters. Electric meters. You see, everybody's house is having electric meters. Now this meter measures electricity in terms of this kilowatt hour. This is also called as 1 unit. 1 unit. That is equal to 1 unit of electricity is equal to 1 kilowatt hour. Kilowatt hour. kWh. kWh. Kilowatt hour. So 1 kilowatt hour means if 1 kilowatt energy is consumed for continuously for 1 hour. If 1 kilowatt energy is consumed continuously for 1 hour, then it is called as 1 kilowatt hour. Understood? If 1 kilowatt energy is consumed for continuously for 1 hour, then it is called as 1 kilowatt hour. Understood? Yes. Another unit for this is power is horsepower. It's also called as HP. It's called as horsepower. Have you heard this word, horsepower? Where you have heard this word, horsepower? In book. Which book? This book only. Okay. This chapter you have to study. So horsepower means what? See, the power is generally horse is considered to be a very powerful, no? Because it can pull the vehicle, cart, and so on. It can pull different things. Isn't it? So horses are used for that various purposes. For example, the horse was used for running. The riders used to sit on the back and then they used to take them from one place to another. And the horse can work for continuously for a long period of time. So from there, this word horsepower has come. Okay. So horsepower, 1 horsepower is equal to 746 watts. This is the relation between horsepower and this watt, 746 watt. 1 horsepower is equal to 746 watt. Okay, write down a numerical now. Write down a numerical. An electric pump lifts 1000 kg of water an electric motor or pump lifts 1000 kg of water in half an hour. In half an hour. Calculate the calculate the power of the pump. Calculate the power of the pump. Take G is equal to, take G is equal to 10 meter per second square. Take G is equal to 10 meter per second square. Small g is equal to 10 meter per second square. Question is clear? Also convert the power in kilowatt hour. Also convert, after, repeat after. G is equal to 10 meter per second square. Also calculate the power of the motor, the power of the motor in, power of the motor in kilowatt hour, comma kilowatt, comma horsepower. 3 units you have to convert also. Now see this here. You see here, there's an electric motor, and it is lifting, how much power it is lifting, how much water it is lifting, 1000 kg. Okay. So force is equal to what? Mg. So M into G. G is how much? 10 meter per second square. That will give you 10,000 Newton. Got it? Eh? Now, according to the question, the pump is lifting water from here to here, and this length is given as how much? Is it given? You add in the question, write down where you have written lifts, the pump lifts 1000 kg of water to a height of 35 meter, to a height of, to a height of 10 meters. You take to a height of 10 meters, lifts water up to height of 10 meters. So here it is, here you see work done is equal to force into displacement. Force is how much? 10,000 Newton multiplied by displacement is what? 10. This is Newton and this is meter. So that is equal to 1, 2, 3, 4, 5 Newton meter. That will be joules. Clear? This point is clear? Anna? Now it says power. Power is equal to what? Work upon time. Yes. Work done is how much? 1, 2, 3, 4. This much. Anna? Time is how much? Half an hour, na? 30 minutes. 30 into 60. Two zeros will be cancelled. That will be what? 10,000 upon 6 3 is 18. Na? 18. So if you will solve this, this will be in joules. Divide it and tell me the answer. What is the answer? Do you know how to divide? Divide and tell me what you get. Yes, divide beta. You are not able to divide? 555. Very good. 5555.5. Okay. What? Right? Now you have to convert it in. You have to convert it in kilowatt. You know. First part you have to convert in kilowatt, na? So 5555.5 divided by how much? 1000. Na? That will be in kilowatt. That is equal to 3 place of decimal 5.5556, you can say, kilowatt. Right? Now you have to convert it in kilowatt hour. That will be what? 5555.5 divided by what? 36. How many zeros were there? Kilowatt hour. You know? 36, then 5 zeros. 1, 2, 3, 4, 5 zeros. Na? Solve this, you will get your answer, second part. And third part was horsepower. So 5.5 divided by 746. And this will give you what? Kilo horsepower. Is it okay na? You can see na? Okay. Hurry up. So do it in your fair notebooks. Then I will give you another question.